Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Kadir Kambi Hamdan. My number matrix CE190216. I will present how to build block diagram in Simulink. Alternatively, you can hit the Simulink at the top of the MATLAB window as shown here. Once you click on blank model, a new window will appear as shown below. Open the file Simulink by entering the following command in MATLAB command window. Alternatively, you can load with using the open option file in menu in Simulink. The following model window should appear. A new model can be created by selecting new from the file menu in Simulink window. There are several general classes of block with the Simulink library. Source used to generate various signals. You can see. And sink used to output or display signal. Continuous time system elements. Discrete linear discrete time system elements. Math operation contains many common math operations. Pod and subsystem contains useful block to build a system. After that, we can line transmit signal in the direction indicated by the arrow. Line must always transmit signal from the output terminal of one block to the input terminal of another block. One exception to this is a line can tap off of another line, splitting the signal to each of two destination blocks as shown as below. Line can never inject a signal into another line. Line must be combined through the use of block, such as a summing junction. Each signal can be either a scalar signal or a vector signal. For single input system, scalar signals are generally used. For modifying block, a block can be modified by double clicking on it. This dialog box contains fields for the numerator and the denominator of the block's transfer junction. By entering a vector containing the coefficient of the desired numerator of denominator polynomial, and desired transfer function can be entire. For example, to change denominator, and hit you can see we change the denominator. Okay. The step block can also be double click, bringing out the following dialog box. Before running a simulation, a system first open the scope below by clicking. Then to start the simulation, either select run from the simulation menu, play top of the screen. The simulation should run very quickly and the scope window will appear as shown below. So we can see, since the new transfer junction has a very fast response, it's compressed into a very narrow part of the scope window. This is not really a problem with the scope, but with the simulation itself, Simulink simulate the system for a full 10 seconds, even though the system has reached steady state shortly after 1 second.
Hi and a very good day. My name is Chong Shin Nin, and I will explain Lab 1 control part 1, 1.5 under dam block diagram, under dam system. So we know that in under dam system move quickly to equilibrium, but it will oscillate about the equilibrium point as it does so. So as you can see here, this is the plot diagram for the under dam. So this is the transfer function for under dam. So this value, we get it from the reference book as our reference lah. This value for our reference value for this lab. So we can, if we double click the transfer function, we can simply change the value at here, the parameter here, the numerator coefficient and denominator coefficient. We can simply change the value. We can know that the parameter A and B, which is the 9 over 2s plus 9 here. This is the 9 here is the parameter B. So 2s here is the parameter A. So we can simply change the value here to see the difference of the output waveform, output transient response. So let us see the waveform here. Okay, we click run. Okay, so this is the transient response for under dam. So as you can see here, the area here, this is the rise time. And for the rise time to go down here, this area is called for the maximum overshoot. And then after that, here, the area here is the settling time. So we can know that the rise time, if the value here at the transfer function here, if the value increase, it will take more time to increase the rise time. For the maximum overshoot, if we increase the value, the peak of the waveform will become more stable. If we decrease the value, it will become the peak on the graph waveform is unstable. So next, for the settling time, we can know that if the value of settling time decrease, the graph will be stable. But if we increase the value of the settling time, the graph will become, the area here will become unstable. So it all depends on the transfer function value that we assign. So that's all for my part. Thank you.
Assalamualaikum and hi. My name is Nur Aini Nadira binti Kamarul Arifin and my metric number is CE190049. So for this lab 1 control, for my part, I will present the overdam plot diagram and the transient response waveform. So for the block diagram, the value of the transfer function we get from our group, get from the Control Systems Engineering 6th edition book by Norman S. Nice. So from the book, we make it as a reference and we take the equation and we run the simulation like this. So for the block diagram, 9 for the transfer function block, 9 is the amplitude, S2 is for the time rise, 9S is for the maximum overshoot, 9 is for the settling time. So first we see one. So the transient response waveform will show like this. Next, I will show what will happen if we change the value for the denominator coefficients. This one. One. So for the time rise, the slope will get higher like this. It will increase this. So for the maximum overshoot, try to lower. Run. So the maximum overshoot will be like this. The response will be like this. So like this. Then for the settling time, so for the settling time, the response will be like this. It is not. We get the value back. Then stable state because the maximum overshoot is lower than the settling time. So for the amplitude, it's lower. So it will be like this. The lower the amplitude, so the amplitude will be get decreased like this. So when we change the value of the settling time to 5 and the amplitude is 9, it will go infinity like this. So there's no stable state here. Okay, so that's all from me. Thank you.
Hello, Assalamualaikum. My name is Syamil Bakri bin Ibrahim. My metric card is CE190170. So today I would like to explain about the slab control system for the slab 1. So my part is for the critically damped. So this is the block diagram. So I'm not going to explain about this block diagram because my group members are going to explain about this block diagram. So I'm going to show you about the scope, the graph. So this is the result that we get from the plot diagram. So as you can see, this graph have 3, which is time rise from here to reach the time rise, and then from the time rise from the time rise to the straight line is maximum overshoot, and the straight line is the setting time. So yes, we can see the difference, which is we need to change the value from this plot diagram. So okay, I try. Okay, if I change to the lower value, which is 5, and I apply. Okay, so we run. Okay, after we run, we get the result for the scope. So yes, as you can see here, the time rise is a bit slower to reach. Okay, the time rise is a bit slower, and then the maximum overrise is also slower to reach to the setting time, and then the setting time is remain the straight line. So yes, this is the difference between is when you change the value. So I take these rumors is from the books, which is this is the rumors for the critically dam. So the different dam is the dam over dam is different rumors. So this is this is the rumors that I'm going to take is 9 per s square plus cs plus 9. So just now I changed to the lower value, right? So I change back to the same number that I do just now. So yeah, so I run it back, and then okay, this is the result that I get just now. So that's all from me for this graph for the critically damped. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Rizwan Shakib bin Muhammad Hamzadi. My matrix number is CE190085. So I will explain about my part for leg 1 is undamped. So here we have the block diagram. We have step, we have the transfer FCN, and then we have the scope. So here we have the 9 over s square plus 9. 9 on the above is the amplitude. S square is the time rise, and 9 is the settling time. So this part is not my part, because my group member will be explain about this, but my part is the output. So first we have to run, and then we have to open the output. So this is the output that I got for my part. So from here to the top is the time rise, and then here to the here is the settling time. So this is the output. So it's called a transient waveform, transient response waveform. So this is the waveform, output waveform that we got from the block diagram just now. So I think that's all from me. Thank you. Assalamualaikum.